Today's lesson is about how to use the first derivative to find maximum or minimum. As we know, there are two types of maximum and minimum. One is local. One is absolute maximum or minimum. For the local one, you can use the first derivative to find local maximum or local minimum. First of all, you will figure out the first derivative. Then you set up the first derivative equal to 0 to solve for this x. Then you use a neighbor value test to decide its local maximum or minimum or stationary inflection point. If you're looking for the absolute maximum or minimum value, you have to compare the local maximum or minimum to the boundary value. Now let's go to number 1. Consider the curve this. The domain is between -1 to 3. Use the first derivative to find the local maximum and local minimum points. Now the first step is you will get the derivative of f of x equals. We got to use the power rule to figure out the derivative. So we have 2 times 3. Then 3 minus 1 is 2. Minus 9 times 2. X to the first power plus 12 times 1. Derivative for x, that is 1. Then plus 0. Let's organize. You will get the 6x squared minus 18x plus 12. Then the second step, you need to put this derivative equal to 0. So 6x squared minus 18x plus 12 equal to 0. You can solve this by graphing calculator or just do by factoring. So I take 6 as a common factor. You will get the x squared minus 3x plus 2 equal to 0. So you have x minus 1 times x minus 2 equal to 0. So your x1 equals 1. x2 equals 2. Then the third step, we will get the y1. We need to substitute 1 for this x. So you get 2 times 1 to the third power minus 9 times 1 squared plus 12 times 1 plus 2 equals 7. For y2, you will substitute as 2 times 2 to the third power minus 9 times 2 squared plus 12 times 2, then plus 2. So you will get 6. Now we got these 2 points. It is 1, 7, and 2, 6. Now we will analyze for these 2 points its local maximum or local minimum or stationary inflection point. Let's go to the fourth step. We will classify through this neighbor value test. So at x equal to 1, we will get the sign when x equals 1 minus 0.1 and 1 plus 0.1 for derivative of function. That is positive to 0, then to negative. That means going up, then it's a maximum value, then going down. Therefore, at x equals 1, there is a local maximum. Then for x equals 2. You will find the sign for f prime of 2 minus 0.1 is a negative, then go to 0, then here is a positive. Therefore, it's going down, then go to minimum, then going up. Therefore, at x equals 2, it's a local minimum point. For number 1, we already figured out the local maximum, that's 1, 7. Local minimum is 2, 6. For second question, find the absolute maximum and absolute minimum point for this curve when x is between -1 to 3. In this time, you need to figure out the boundary value, which means f of -1 and also f of 3. Then compare this value to the local maximum, local minimum to figure out the absolute maximum and absolute minimum value. So for f of -1, you will substitute like this: 2 times -1 third power minus 9 times -1 squared plus 12 times -1 plus 2 equals -21. For f of 3, you will get the 2 times 3 to the third power minus 9 times 3 squared plus 12 times 3 plus 2 equals 11. This time you will compare this 7, 6, -21, and 11. Then you will see the absolute maximum is 11 and absolute minimum is -21. For number 2, consider the function f of x equals this. The x is not equal to 0 and x is between -2 to 5. Use the first derivative to find the local maximum and a local minimum point. Therefore, the first step, we will working on f prime of x. For the 5x, it will be 5 times 1 minus 0 plus 1 over x squared. I can write down x to the -2nd power. So the derivative for x to the -2nd power will be -2, drop down. X we do the -3rd power. So we organize it will be -2 over x 3rd power. So I will write down -2 x to the 3rd power. So we organize, you will get the 5 minus 2 over x to the 3rd power. Second step, we will make a 5 minus 2 over x 3rd power equal to 0. By graphing calculator, you will get the x equals. You will get 0.737 for the roots of this equation. Now the third step, we will working on the y1. Let's label here as x1. You will get the 5 times 0.737 minus 3 plus 1 over 0.737 squared equals 2.57. So we got this point, that's 0.737 and 2.53. Now for the fourth step, we need to classify to this point by using neighbor value test. You could say this is a negative or here's a positive. Therefore, at x equals 0.737, this will be going down and then 0, then going up. So it's a local minimum point. For second one, find the absolute maximum and absolute minimum points. For this question, you have to be very careful because this is a rational function. We do have a vertical asymptote line. For the vertical asymptote line, we will set up the denominator x squared equal to 0. So you get the x equal to 0. This is a vertical asymptote line, which make it possible there is no absolute maximum or absolute minimum value. We're still working out the boundary value, that is f of negative 2 equals 5 times negative 2 minus 3 plus 1 over negative 2 equals. That is negative 12.75. This is an accurate answer, so you don't have to round to the 3 significant digits. For f of 5, we will work this out. It's 5 times 5 minus 3 plus 1 over 5 squared equals 22.04. Since when x close to 0, the y will be positive infinity. Therefore, there is no absolute maximum value. We only have absolute minimum value is negative 12.75.